All right, we are in section 6.4, where we are going to investigate similar figures. When we get into shapes and figures of most kinds, we are now sort of diving into the introduction to geometry, trying to figure out shape definition and how it's represented um, as they're shown. So first thing we got to do is be able to identify the different kinds of labeling that will be undertaken when it comes to discovering what these shapes represent. So first off, we look at the very first item we have here, and that is we have like a point A. All right. So having a point can represent several things when it comes to establishing geometric figures. It could be on or on the edge of a particular object, or it could be something that's inside a particular object. All right, and it's usually represented by a point and denoted by a letter. All right, in this case, it was point A. All right, points can also be used to represent both uh, lines, line segments, rays, and angles. So if you look here, we have 2 points, B and C, but it's connected to a line that goes to infinity in both the left and the right direction. Anytime you see arrows pointing in the left and right direction, it gets denoted like this, line BC. When there are no arrows at the endpoints of a line, it is actually called a line segment. All right, so a line segment has an actual stopping point. So if you're ever asked what's the difference between a line and a line segment, lines go on forever in that direction in both the left and the right direction. Line segments have an actual stopping point. In this case, the stopping point was between B and C in this particular example. Rays, on the other hand, have a starting point, which is right here, and go on forever in one direction. All right, it can go to the right, it can go to the left, it can go up, it can go down, it can go on different angles, whatever the ray needs to go, that's where it goes. And if you notice here how it's labeled, ray BC, B is the starting point, C is where it's going on uh, to infinity in that direction, so that's how it is labeled. It cannot be labeled like this. All right, that's a no-no. You can't do it that way because the starting point is at B. So you must be able to label it correctly. The last thing that we have here for uh, different terms is being able to identify an angle, okay? And anytime you are identifying an angle, you either need to use 3 points to make an angle. In this point, they're using A, B, and C. And B has a very specific name. All right, B is called the vertex. All right, the vertex is where it's a specific point where it's essentially 2 rays that are connected at a single starting point. So the starting point is at B, and then you have a ray to A, and it's going on to infinity going this way, and you have B, and you have another ray that's going to C that's going to infinity that way. Okay? There is actually two different ways that you can label this. You could label it with um, all 3 points, angle A, B, C, being certain that the middle value is always going to be the vertex, okay? So you could also write this as angle CBA. That would be correct because B is still the vertex. But for the most part, people usually try to uh, use it in alphabetical order as they can, just being certain that the vertex is always the middle value. Or if there's no other angle that can be represented it as, in this case it's just one angle, you could always represent it as angle B, which is the vertex. All right, sometimes that works, sometimes that doesn't. I would probably prefer you to make your labeling um, with this representation. Okay, sometimes uh, when you are doing with this is when you have actual polygon shapes, and it's easily identified what that angle is, so you could use it in that aspect. So um, so those are the different diagrams, to help us represent similar figures in geometry. So if we look here, we have a shape. In this case, this shape is a parallelogram or a quadrilateral, depending on the proofing of this. But that's proving and stuff like that gets into the actual geometry. But for our sake, we can call it a parallelogram. And how they named it was they just named it with the endpoints A, B, C, D. Okay, so quadrilateral A, B, C, D. The endpoints are right here. Okay. So similar figures, it states that are shapes that have the same shape but not the same size. So what that means for us is we have to be able to identify the corresponding parts. All right, the corresponding parts to a particular shape have specific side lengths and specific angle measures. Okay. Um, when it comes to similar figures, when it comes to the corresponding sides, when it comes to corresponding sides, the corresponding sides must be proportional. When it comes to the corresponding angles, the corresponding angles must be equal, or we're going to hear another term, congruent, which is another term for equal. All right, so sides must be proportional, corresponding angles must be congruent or equal. All right, so if you look here, we are given two triangles that are similar. They want us to express this with symbols. All right, so first off, we got what are the corresponding angles? All right, so the corresponding angles in this particular instance, if you look here, this looks like it's 90 degrees. And so this one also looks like 90 degrees. So we can say that angle B and angle F are corresponding. Next, I can look over here. I can look at this angle, and this angle appear to be the same. So I could say that angle A and angle E are corresponding angles. And then finally, the last one right here, I'm just making little dashes to represent that they're the same, or at least they're corresponding. And in this case, angle C and angle G are corresponding angles. All right, so those are the three corresponding angles for that similar figure. All right, now we're going to look at the corresponding sides. So the corresponding sides, if you look here, see how I have the one tick mark here. I'll make it a different color. One tick mark here, one tick mark here, the 90-degree angle, the 90-degree angle. That means that I'm assuming that these two are in fact similar, okay? So they're similar. Write this in. So what we can say is line segment AB and line segment EF are corresponding sides. The next one would be over here and over here, which means that BC and FG are corresponding sides. And then the last pairing would be here and here. So that means that AC and EG are in fact corresponding sides. So sometimes similar figures can be like mirrored images of each other. So if you look at this particular example, we have basically a mirrored image, and then the figure on the left is a little bit smaller. So first off, it says these two figures are similar. Anytime they give us a statement like that, we have to assume that it's true. Once we are given a statement that they are similar or that if they are congruent, we have to now make the assumption that they have corresponding sides that are proportional and corresponding angles that are equal. All right. So looking at this, uh, going with the corresponding sides first, it looks like I got AB as one side, line segment AB, and it looks like this and this go together. So it looks like FG is corresponding to AB. The next one I got here and here. So I can say that AE and FJ are corresponding sides. I can go here and here. So BC, line segment BC, and the line segment GH, corresponding sides. I can go here and here. CD, line segment, and HI are corresponding sides. And then finally, to finish up, I have line segments here and here. So line segment ED or DE. Actually, I'll keep it in alphabetical order. Keep it in alphabetical order. So DE and HI. All right, so those are the corresponding sides for these particular similar figures. Now I go over here. Um, I look at, I'm going to start with A. So it looks like angle A, and it looks like angle F are corresponding. The reason why I use that is because A has the number and number in between them, and then I got a variable and a number. That just assumes that they're with the, in fact, with the corresponding. And also, if you look here, I got the first letter A and the first letter F. That also kind of helps too. So now let's look at B, angle B, and I would say that G is your corresponding angle. Okay, so looking further, I can say let's go angle C, and I'll go angle H, because you got C and H. We got angle D, and I'll say that angle D and angle I are corresponding. And to finish up, looks like I got E and angle J. So if you look E and J, so it's written second, it's written second. So that's how we can establish that. And then at the bottom here, it says, with the given information, find the length labeled X. So if you look here, how you would depict this is saying that it's proportional would be like, okay, so I said that FG and AB are corresponding. So that means that they are going to share a fraction. So if I say AB over FG, it's going to be proportional to AE over FJ. So that's these two are corresponding. And you have to be consistent with the labeling. So I put this figure, we'll call this figure number 1, we'll call this figure number 2. So all of the side lengths for number 1 are on the top. All of the side lengths for shape number 2 are on the bottom. And then it's just a matter of placing the values where they're located. So AB was 3, so I put 3 over FG, which is X, is going to be equal to AE, which is 4, over we got FJ, which is 5. And then now that we have a proportion, we can do the exact same thing that we have been doing the cross products here and here. So this turns into 4x is equal to 15, dividing everything by 4. 15 divided by 4 gives us x is going to equal 3.75. So x in this case would be 3.75. Last thing we're going to talk about is congruency. Congruency means that two figures are congruent. They have the same size and the same shape, all right? Congruent, again, is another way of saying equal. So they have equal size and equal shape. So being congruent means that the corresponding angles are the same and the corresponding sides are the same. So what we have here are two congruent figures. Okay, so two congruent figures. It says show, uh, use symbols to show sides are congruent. So here's how you show that sides are congruent. So like L and O, you make a tick mark here, and you can make one mark here. So that's stating that HK and LO are the same. You can go here and make two marks, which means you make two marks here. So H and I and L and M are the same. You can make three marks here, and that shows that IJ and MN are the same. And then finally, you can go here 1, 2, 3, 4, 1, 2, 3, 4. So that's JK and NO are the same. So that's how you determine congruencies for the sides. For the angles, same, that's 90 degrees. So that's represented as like a square. That's represented like a square. You can write like one mark here, one mark here, two marks here, two marks here, and you can go three here. And then that represents that those corresponding angles are congruent. And so they basically have some questions here that if two figures are congruent, what is the length of H? K. So HK is right here. We know that the corresponding angle is LO, and they're telling you that it's 12 feet, so it's also 12 feet. The other question they ask is if the two figures are congruent, what is the angle measure of M? So here's M we're needing to find. The corresponding angle to that is I. It says it's 110 degrees. Well, guess what? Angle M is also 110 degrees. And that is being able to investigate similar figures. Hope this helps. Until next time.